All right, this is Unit 8, Lesson 3, Tests for Parallelograms. And the learning objective for today is that you all will learn to identify and use tests to show that a quadrilateral is a parallelogram. So what do we remember about parallelograms? First, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other. Finally, opposite sides are parallel. That's where we get the name parallelogram in the first place. So let's take a look at our first test, which says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So here I have one pair of opposite sides, RS and UT, that are congruent, meaning that they're the same length, and that's noted by the double hash mark here, and it's written symbolically here. I can say the same about side RU and ST being congruent as noted by the single hash mark here and written symbolically here. So if I have a quadrilateral and it's labeled as having both pairs of opposite sides as congruent, then this can be considered a parallelogram. However, if I have another quadrilateral and only one pair of opposite sides is labeled as congruent, but nothing is said about the other side, then I cannot call that a parallelogram. All right, our next test says that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So here in this case, we have angle H congruent to angle F as noted by the single arc. And then we have angle E congruent to angle G as noted by the double arcs, right? And these are two pairs of opposite angles. And because they're congruent, quadrilateral EFGH is a parallelogram. Now I have two additional tests. And theorem 8.8 says that if one pair of opposite sides of a quadrilateral is parallel and congruent, then the quadrilateral is a parallelogram. So here we're only dealing with one pair of opposite sides, but they are parallel as noted by these bold arrows, and they're congruent as noted by the hash marks. So quadrilateral ABCD would be considered a parallelogram. All right. And then theorem 8.9 says that if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So here in this figure, you can see diagonal AC and diagonal BD both bisect each other or cut each other into two congruent segments. All right. E being the midpoint of each diagonal. So quadrilateral ABCD is a parallelogram. So let's look at some examples. Here we have to determine whether each quadrilateral is a parallelogram. And if it is, we'll give a reason. So here in example 2, I have one pair of congruent opposite sides and then another pair of congruent opposite sides. So that means that this is a parallelogram because I have two pairs of congruent opposite sides. Here I have two pairs of congruent sides, but they are not opposite sides as congruent. So no, that is not a parallelogram. And now it's your turn. Pause the video and see if you can get the answers to F and G. And here are your answers. F is a parallelogram because these two diagonals bisect each other. And G is a parallelogram because these two opposite sides are both congruent and parallel as noted by the alternate interior angles, if you consider these two as being cut by a transversal. The alternate interior angles are congruent. That makes them parallel. So I have some additional examples here. You can pause the video now before you get the answers, and I'll just release them one by one. All right, thank you guys.